Hello and welcome back. This will be the last video in section 3.4, and this is essentially just a very nice trick that will help us look for roots of polynomials. And here I have an example function, f of x equal to 3x to the 7th minus 2x to the 5th minus 4x to the 4th, minus x to the 4th plus 7x squared plus x minus 3. And this is going to be about sign changes. So when we look at the coefficients of a polynomial, they might change from positive to negative or back. So here we look and we see a plus 3 goes to a negative 2. So we have a sign change. It goes from a positive number to a negative number. Here we've gone from a negative 2 to a negative 1. No sign change. However, from here to here, we've gone from a negative number to a positive number. So here's another sign change. From 7 to 1, there's no sign change, but from 1 to negative 3, there is another sign change. So here, this function will have 3 sign changes, and this will tell us something about the roots of the polynomial. This is just a clever little result. This is by Descartes. So the Cartesian coordinate system, the xy plane that we're familiar with, is named after Descartes. So he found that the number of positive real roots is equal to something to do with sign changes. We can also calculate the number of negative real roots with something to do with sign changes. So the way this works is the number of positive real roots is just equal to the number of sign changes in the function, or you could be off by an even number. So for instance, up here, we had 3 sign changes in f of x, so the number of positive real roots could be equal to 3, or maybe we're off by a positive even number. Let's say we could be off by 2, so there could be 1 positive real root. So it's either going to be 3 or 3 minus some even number. The same way with negative numbers, except that we have to look for the negative sign changes in f of negative x. So there's just that little extra negative sign that pops in, but again, you just count sign changes, and this will tell you how many negative roots will there be, but we also could be off by an even number. So let's go through a quick example of this and we'll finish this section. So determine the number of possible number of positive roots and negative roots. So let's see how many sign changes do we have. From plus 1 to negative 14, sign change. From negative 14 to positive 71, that's another one. From 71 to negative 154, that's a third one. And from negative 154 to 120, that is a fourth one. So we have 4 sign changes. So this means that the number of positive real roots is either 4, because it could just be equal to the number of sign changes, or we could be off by an even number. So it could be 4, or 2, or even 0, because this would be 4 minus 4. So we'll just count backwards, skipping numbers. So it's either going to be 4, or 2, or 0. You can't have a negative number of roots. You can't have a negative number of things, but we can't have more than 4 either. Since this is a degree 4 polynomial, we know that it has only 4 roots. So that's our limit. So let's look at f of negative x to look for the negative roots. So f of negative x is going to be negative x to the 4th minus 14 negative x cubed plus 71 negative x squared minus 154 times negative x plus 120. So far so good. Let's simplify this. Negative x to the fourth power is negative x times negative x times negative x times negative x. Two of the negative signs cancel, the other two of the negative signs cancel, and we'll just get x to the fourth. Negative 14 times negative x to the third power, all of those negative signs cancel. 71 times negative x squared, well, both those negative signs cancel. Negative 154 times negative x, again, all those negative signs cancel. And we just get 120. So there's no sign change here. There's no sign change here. No sign change there. Oops. X. And then no sign change there. So there are 0 sign changes. Specifically in f of negative x. So there are 0 negative roots. Let me rephrase this. So there are no negative roots. So one thing to keep in mind is that this is only talking about real roots. So this could have complex roots, this could have imaginary roots, but as far as real roots go, we can either have 4, 2, or 0 positive ones, and there can't be a negative real root. So it's just a nice easy way to see how many roots a polynomial can have.